In this video, I'm going to show you how to compare the slope-intercept form of a line and the point-slope form of a line, excuse me. And so I just kind of want to introduce the different forms here and kind of compare them and show them how they work similarly and how they're different. So first, let's just talk about in general point-slope form of a linear equation. And this is that you can write the equation of the line in slope-intercept form, which is y equals mx plus b. That is different than point-slope form. But you can write that equation when you know the slope, which is the m part of that equation. And you can also write this equation when you know the y-intercept, which is the letter b of that equation. But you can also use slope formula to find the equation of a line when you know the slope of the line, and if you know only one point. So I'll show you how these are different, similar and also different. In this formula, slope-intercept form, which is y equals mx plus b, you know the slope m, and you also know a point on the line, but specifically it's the y-intercept point. So this point B is really the point on the graph 0, b. It's a special point because this point crosses your y-axis. And in this equation over here, point-slope form, again, you still have the same slope as whatever slope you had here, but the point on your line in this formula will be any random point. And they call it x1, y1 because it is the one point that you know. And this may or may not be on the y-axis. Generally, it's not. And so what I like to say is it's a random point on the plane. And so that's where these lines are very similar. They both share that they use m in the function, your slope, and they also use one point, but the difference is the type of the point. And so I want to give you a couple examples of points that we have where you would see, like for this one, a y-intercept point, but then also how you can use point-slope form for a different random point also on the same line. So because this point is 0, 5, notice how it fits that format for your b. For this point, you could use slope-intercept form because that is the b of the function. But if I were to use this point in my equation, I have to use this one here, point-slope form. Now, in order to use either, I need to know my slope. And so again, I'm going to just kind of quick review how to find slope of a function. And slope, which is usually used as the letter m, is our y2 minus y1 over x2 minus x1. So I'm going to quickly find my slope before I use either of those equations that also need slope in them. So my second y value is a 3, my first y value is a 5, and I'm going to subtract my second x value 1 on the bottom, and then my first y value, x value 0. 3 minus 5 is going to be negative 2. 1 minus 0 is 1. So my slope here that I'm going to use is negative 2. So negative 2. And now if I'm going to use, like I had said here, this point 0, 5, I know 5 is my b. So I can use y equals mx plus b because I know my slope m and I know my b. So that would be y equals negative 2x plus 5. But if I were to use this other point here, 1, 3, I have to use this function because this point is not on the y-axis because my x value is not 0, I know that. I need to use this formula because it is for a random point on that line. So y minus my y value 3 will equal my slope, which I found here, negative 2, and then in parentheses x minus my x1 value, or the value 1. Now, both of these functions are the same. I'll show you how to convert this in a later video, but this would be a point-slope formula for the line, and this is a slope-intercept. Now look at these 2 points. Neither of them is in this format, 0, comma, a number. And so I'll show you the 2 equations you could use for point slope form. Again, you will get the same slope-intercept form if you convert, which I'll show you in another video. But first I'm going to calculate my slope, which is going to be my second y value minus my first y value, and then divide by my second x value minus my first x value. So 2 minus -4 is -2, and 6 minus 2 is 4, and if I reduce, -1/2 is my slope. And now, depending on which point that I pick, y minus the y value of my point, let's say I pick this first point, would be 4 here. My slope goes here, -1/2, and then in parentheses, x minus the x value of my point, which is 2 here. And so notice my x value goes here, my y value goes there in my formula. And so here -4 and here -2. Also something to notice is that your formula has opposite signs as your point does. But if I had used the other point, another equation you could have written was y minus this y value 2 is equal to -1/2, and then in parentheses x minus my x coordinate, or 6. Again, notice how the point is plugged in, and then because of these minus signs, the equation is opposite signs as your point. Now the last set here that I have, maybe you want to try and pause the video and come up with the 2 point slope formulas, but first you're going to have to calculate slope. So go ahead, try it out, hit pause, and then when you're ready to check your work, hit play. For slope, we're going to take my second y value, -3, minus my first y value of 3. Then on the bottom of my fraction, my second x value, -5, minus my first one, 1. The top for my fraction for my slope is going to be -6. The bottom is also -6, which means I have a slope of +1. Now I'm going to use that slope in my point slope formula for either of those 2 lines. Again, you really only need to pick one, but these would be the 2 functions that are possible. Y minus a y value of 3 equal to my slope of 1, and then x minus my value of my x coordinate here, 1, or y minus -3, and minus a negative is going to make that a positive, and then 1, and then in parentheses, because my slope was 1, that goes there, x minus -5 minus a negative is going to turn that to a plus. And so those would be your 2 functions for point slope. Now I have a couple things to kind of show you down here with the equivalent equations, and so I'll talk about that, and then this video will be done. When you transform a point slope form into slope-intercept form, you will notice that you will have exactly the same slope when you transform, and that you will also have the same y-intercept. So notice how this is going to convert to be the same. They'll be equivalent. And just to refresh, the main point of this video is that these 2 formulas are used for different things. We need a point for point slope form, but this is going to be a random point. It's called x1, y1, versus the point for slope-intercept. The point is your y-intercept, which is specifically 0, b on your graph, and the b is used in your function. But again, both of these use slope. And it would be a really great idea for you to memorize y minus y1 equals m, and then in parentheses x minus x1, and then also y equals mx plus b. So those 2 formulas we're going to use a lot in our Algebra 1 unit.